Hello. Welcome back to the channel. So let's do some more questions on separable differential equations, which are based on word problems. So in this question, we have been given that an investor places some money in a mutual fund where the interest is compounded and also the interest rate fluctuates between 4% and 8%, right? So if we assume that the amount of money is represented as this, so the amount of money is a function of time, where your B is in dollars and T is in years, your dB by dt, which is the differential equation, is given by this formula over here. And you can clearly notice over here as well, since we have to first understand the context of this question, we have been given that the interest rate fluctuates between 4% and 8%, right? And we also know that our sine t fluctuates between -1 and 1. So this expression over here clearly lies between 0.04 if sine of t is -1 and 0.08, which is 8% if your sine t is 1 over here, right? Since we know that sine t fluctuates between -1 and 1, so this expression fluctuates between 0.04 and 0.08, which is indeed 4% and 8%. So definitely it makes sense that our interest rate fluctuates between 4% and 8% in this case. And based on this differential equation, so now we have understood the context of this differential equation. And now based on this differential equation, we have to solve for b as a function of time. And also we have to solve the balance, which will be at the end of 2 years. So since it's compounding and the rate is always fluctuating between 4% and 8%, so we'll definitely expect a higher value than $1,000, right? Because our interest rate is always increasing. So we'll definitely expect an increase in the amount of money deposited into the mutual fund, right? So let's solve this differential equation over here. Your differential equation is dB by dt equals 0.06 plus 0.02 sine t times b in this case. And again, since this is a separable differential equation, we'll separate the similar variables on one side. So b will be moved to this side, we'll move dt to this side over here. And if we do that, and now you notice one thing as well, that on your left hand side you have b in your denominator. So if you're dividing an expression by b, you also have to make sure that your b, you'll also have to add a constraint that your b is always not equal to 0. So the amount of money in the account, the initial amount of money in the account is never 0. So we'll have to take this fact into consideration, that our b, which is the amount of money in the account, is never 0. And on the right hand side, you'll have simply 0.06 plus 0.02 sine t times dt in this case. And now we can take the integral on both sides. If you take the integral on both sides, the left hand side is ln absolute value of b, and the right hand side would be 0.06 t plus the integral of sine t is minus cos t. So this expression will be minus 0.02 cos t, and we'll add a constant of integration as well. And now since we know that b is our amount of money deposited into the mutual fund, we know that the amount of money cannot be negative, right? So in this case, we can remove the absolute value sign as well. So this would be equal to ln b, and the right hand side would still be 0.06 t minus 0.02 cos t plus c in this case, right? So now we have this expression over here. Since we want to solve for b as a function of time, we can take the exponent on both sides. So if we take the exponent on both sides, it will simply be b on the left hand side, and on the right hand side it will be e to the power 0.06 t minus 0.02 cos t plus c in this case. And since this e to the power c is a constant term, we can simplify this expression as simply e to the power c times e to the power 0.06 t minus 0.02 cos t in this case. And now since we know that c is the constant of integration, it can be any real value. E to the power c will also be any real value. But since this is an exponential function, we know that the exponential function is always positive. So let's assume let's assume another constant a to be e to the power c, and we know that e to the power c is always greater than 0. And now this equation will simply be transformed to b equals a times e to the power 0.06t minus 0.02 cos t in this case. And this will be your final answer for b as a function of time. And now you can clearly notice, since your a is greater than 0, it's an exponential function, so it's always greater than 0. This balance is always greater than 0 as well. And we also proved this fact that our b cannot be equal to 0. It also satisfies this condition because none of our exponential functions can be equal to 0. So all the constraints that we applied previously to our expression, to our differential equations, are satisfied, right? So we got b as a function of time. Now let's solve the second question over here. We have been given that the initial investment is $1,000, and we have to calculate the balance, which would be at the end of 2 years. So if we know that the initial investment is $1,000, which means that b of 0 is equal to 1,000, right? So when t is 0 years, your b is 1,000 in this case. So let's substitute these values into this equation over here to calculate the value of capital A. And if we do that, it will simply be 1,000 equals a times e to the power. This expression will be 0 minus 0.02 cos t will be, cos of 0 is 1, so it will be e to the power negative 0.02 in this case. And now we can clearly solve for our a value. Our a value will simply be 1,000 times, if we move this exponent expression to this side, it will be basically 1,000 times e to the power 0.02 in this case. So this will be the value for our constant in this case. So now since we have the value of the constant, we can get the final equation as well. So the final equation will simply be, let's copy this over. So it will simply be your b will be equal to 1,000 times, we can combine this exponent with this expression over here, and then it would be e to the power 0.06t minus 0.02 cos t plus 0.02 in this case, right? So now you have to calculate the balance, which would be after 2 years. So we have to calculate the value of the balance when your t is equal to 2. Your balance would simply be, you can substitute t in this equation, it will simply be b equals 1,000 times e to the power 0.06 times 2 minus 0.02 times cos of 2 plus 0.02. And you can leave your answer as it is, or you can simplify this expression and get the exact value. And if you'll simplify this expression, you'll get $1,159.89 at the end. And you have to just make sure that this cos 2, this 2 in cos is in radians. It's not in degrees, it's in radians. So that's it for this video. Again, the main takeaway from this video is you have to be careful when you're dividing your expressions, your differential equation expressions, by some values which cannot be equal to 0. So that is why if there is a case that you're dividing something in the denominator, you have to make sure, you have to apply your own constraints and make sure that the denominator in these type of expressions is not equal to 0. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.